Hello everyone and welcome today to the second day of .vvm virtual conference. My name is Andrej. I'm one of the core developers for the .vvm project, and today I'll be presenting to you two presentations, after which there will be also a couple of other speakers, so there is a lot to be looking forward to. So let's jump straight into my first presentation. So in this presentation, I'll be talking to you about a couple of interesting changes that we did in the recent versions of .vvm. More specifically, we will be looking at code analysis features and what tools do we use in the .vvm ecosystem that you can take advantage of when developing .vvm applications, so that you can get faster feedback about your application development process and some possible issues that may be discovered by our tooling. Then we will be talking about JavaScript translations. What are they? What do we use them in .vvm? And how you can take advantage of them when basically extending our data binding system. And lastly, in this first presentation, we'll be talking about view models, supported types in view models, how this was extended, and collections in view models, and what operations you can basically use when working with these data types. So let's start with code analysis. So what tools for code analysis do we have in .vvm? So I'm pretty sure that all .vvm developers are probably aware of our .vvm Visual Studio extension, which is a really powerful tool. And in .vvm 4.0, we actually introduced another tool which can be quite helpful when developing for .vvm. So let's take a look first at our .vvm Visual Studio extension to just get a brief overview of what I'm talking about. So .vvm Visual Studio extension is a pretty powerful tool that and one of its main features is that it assists you when working with our custom file formats such as .html or .control and similar stuff like that. So it's a tool that offers you IntelliSense, syntax highlighting, auto-completion, and all of these nice, really powerful and advanced features that you can use when developing your .vvm applications. However, it is also capable of basically searching for and notifying you of many possible issues that can be discovered right as you type your application. So, for example, in the example that I am showing here on the slide below, you can see that user is trying to bind within a value binding to a property called title, which is a string property inside a view model, and then by mistake attempted to actually bind to one of its properties called ABC. And as we all know, string doesn't have a property called ABC, and this is something that Visual Studio extension for .vvm is actually can discover pretty fast, because as you are typing your bindings, it's actually being compiled directly using Roslyn, so you get these very nice exceptions, warnings that that string does not contain a definition for ABC, and there are no accessible extension methods, nor is it a valid property. And this is just a really simple example, but just to get the general idea, whenever working with .vvm Visual Studio extension, it's capable of discovering many issues within your .html, .control, and similar files just as you write them. And we wanted to achieve something similar also in the C# part of stuff. And that's why in .vvm 4.0 we introduced a new feature called Roslyn Analyzers, where Roslyn Analyzers is a pretty exciting technology that's basically a static code analysis framework built on top of Roslyn, as the name suggests, that can be used to analyze code written in C# and Visual Basic.NET. And what are we basically using Roslyn Analyzers for? We are trying to discover some issues and common pitfalls which we want to be able to issue warnings for as soon as possible. So as you are writing your code, we want to discover as many potential issues as possible and let you know using your common IDE by issuing warnings. So for example, if you are using Visual Studio and you reference .vvm 4.0 or newer in your application, you should automatically get these .vvm analyzers registered for you under dependencies and analyzers. This should be automatic. You don't really need to do anything in order to get this feature. Just reference .vvm 4.0 or newer, and this is basically not really only tied to Visual Studio. You can use it basically in any other modern IDE of your choice. So for example, Rider or something similar, not only Visual Studio. And just to give you an example of what we can achieve using these Roslyn analyzers, I've prepared some small examples. So first thing, which is pretty powerful, what we can do is basically perform a really comprehensive serializability analysis of your view models. So we can basically pretty easily distinguish whether you are writing a view model or not, because all view models, as we know, need to basically inherit from an existing view model or just implement our .vvm interface. So what we do, we basically find all your view models and then go over it in visual properties. And whenever we encounter a property, we basically perform a serializability analysis. Is this property serializable? Is it supported by .vvm? Because as we all know, view models in .vvm need to be JSON serializable. There are also some other constraints that I'll be talking in later slides, but this is the general idea. View models needs to be JSON serializable so there cannot be, for example, many stuff from the system.io namespace. As you can see in the example below, if I tried to write, for example, a property of type file info into a view model, our Roslyn analyzer with rule .vvm02 would immediately issue a warning notifying you that this is not something which is supported. And this is really helpful if you think about it, because we are trying to shorten the feedback loop. So as you are writing your .vvm view models, you get these warnings immediately and not during runtime, where you discover at much later time that you actually wrote your application incorrectly and it doesn't really work. So this is something that we enhanced in .vvm 4.0, and we believe that these features are really powerful and will help you to identify issues in your .vvm code base much easier. And second example that I would like to show you in connection with Roslyn analyzers is that we are not only trying to identify straight-on issues, we are also trying to avoid users from writing code which could be okay, but is probably problematic. So for example, if somebody was to write a public field inside a view model, for example, public modifiable field, then we know that this is probably something not right, because as we all know, in .vvm you always store your view model state using properties. And don't get me wrong, it's perfectly legal to write fields inside your .vvm view models. For example, you can use private read-only fields if you need, for example, to inject a dependency or some static fields, so for example a constant or something. But writing a public field, that suggests that the user maybe wanted it to get serialized, and that is something not supported. So as you can see in the example below, we also issue a warning for this. So in this example, user tried to write a public int field and it got caught up using our Roslyn Analyzer. So yeah, just to conclude, in terms of code analysis, we have now two pretty powerful tools. The first being, of course, Visual Studio extension for .vvm, pretty powerful tool that has been around for many .vvm versions. And right now, since .vvm 4.0, there is a new tool, basically Roslyn Analyzers for .vvm. So feel free to use them. Watch out for any warnings, as they might also discover some potential issues in your code base. Okay, so this was regarding to code analysis. And right now I would like to approach the second topic of this presentation, and that will be JavaScript translations. JavaScript translations, what are they? What does this concept bring to .vvm, and what are they used for? So to put into simple words, JavaScript translations are small pieces of code that basically provide a JavaScript equivalent to certain .NET methods. And what do I mean by that should be pretty clear from the next couple of slides. So as you all know, .vvm makes it able for you to call certain .NET methods inside your value bindings or your static commands. So in order, however, for this to work, .vvm needs to know their JavaScript equivalence. And I'll describe in a few seconds what do I mean by this equivalence. But you need to understand that since this is not something like Blazor, where we would have a WebAssembly version of the common language runtime running in client's browser, we are relying on JavaScript, so we need to provide a JavaScript equivalent of certain .NET methods. And what do I need by the JavaScript equivalent is that we want to implement similar methods whose observable behavior and their result for the programmer is same as if they were executed by the common language runtime, basically. So JavaScript translations basically define translations from .NET methods to JavaScript, and that's basically the general idea. And why is it good and useful in .vvm? Basically, it allows you to use various .NET methods inside your bindings, because value bindings and static commands can be directly executed, are directly executed in clients' browsers, so there is no communication with the server whatsoever. They are really performant and really good when it comes to the network traffic, because they generate literally none of that. So yeah, this is what JavaScript translations are. And if you are asking, well, what .NET methods are supported, because I told you that not every method is supported, because in order for you to be able to call a .NET method inside your value bindings or static commands, there needs to be registered a JavaScript translation. So if you are wondering what methods can you actually use, feel free to check out our documentation. There is an exhaustive list of many methods that is growing almost every .vvm versions, because lately we've been adding so many. And if you are wondering where to find it, just go to our documentation site, and under concepts, under section data binding, you'll find a site called supported expressions, where you can find all the syntactic expressions that is supporting by our data binding system, along with an exhaustive list of all the supported .NET methods. But I'll speak about these also on further slides. So now the question is, how can I write my own JavaScript translations? Because it may be quite common that you have a pretty handy function, method inside your code base that you would be happy to be able to call from value bindings or static commands. But in order for that to be to compile successfully, you need to first define the JavaScript translator for that. And how can you do that? So the first step is to basically create a generic, to instantiate a generic method compiler. And bear with me, on the next slide I will show you what it actually means, because on this slide it may sound way more complicated than it actually is. And once you have this translator ready, you just need to register it in your .vvm configuration, and after that you are able to use your new .NET methods inside value bindings and static commands. So to give you a concrete example on how this actually looks like, so let's assume for a short period of time that .vvm developers forgot to write a JavaScript translator for the length property on arrays, as we will be implementing it by ourselves right now. So what do we need to do in order to support this? So as you may know, properties in .NET are basically syntax sugar for a backing field and a getter method and a setter method. And when it comes to the length property, the setter is of course not accessible, but we will be using the getter method in order to query how long is the array that we are working with. So we will be providing a JavaScript translation for the getter method of the length property on arrays. So whenever you are basically defining a JavaScript translation, you always need to tell .vvm how to transform individual arguments of that method in order to produce the correct result or the correct action as .NET runtime would. So in this case, we are accessing the 0th element of arguments, which is the secret this pointer or the current instance that we are calling the length property on. And since you may know that .NET arrays are translated to JavaScript arrays when they come to client sides in .vvm, it shouldn't be surprising as arrays are mapping to another arrays, but I'll be talking about which collection translate to what types on client side at some slides a bit later on. But right now, you just have to believe me that .NET arrays are mapping to JavaScript arrays. And since we know this, in JavaScript there is a field called length. Similarly as in .NET, it's just with the lowercase l, not a capital L. And in order for us to finish this translation, we just need to tell that on this first, the 0th argument, we will be accessing its length field. and that's basically it. That's how also the implementation works in .NET. So this is a really simple translation, and the second step that you need to do is to register the translation. And to register translation, you basically need to add it to a correct collection inside your .vvm configuration. And in order for you to do that, inside your configuration, you need to go to the marker property, to the JavaScript translator, and under that, inside method collection, call one of our utility methods. There are many of them, and there is even a utility method for registering translations for property getters. As in this case, we will be adding a property getter translation for type array, and we also need to provide the name of the method that we are registering the translation for. So for that, we can use the name of operator, so that the translation is registered to the length getter, and then we just provide the translation that we created in the step above. And that's basically it. After this, which isn't that hard, you have your own new JavaScript translation. So I think the steps are pretty straightforward. But of course, if you need more information on how to create your own JavaScript translators, feel free to go to our documentation page, where under concepts, inside control development, you will find a page called custom JavaScript translators, where you will get much more information about how all of this process works, how is it implemented internally, what does these arguments that I was translating, what do they actually represent, and along there are also some further examples that you can examine, and that should help you to write your own JavaScript translations. But of course, if you find yourselves in troubles with defining your own translations, don't forget to write us on either GitHub or Gitter. We may guide you with this process, or even if we deem that this feature or this translation could be beneficial also to other users, we might just implement it ourselves and basically add it to the framework, so that every user can basically access the translation in the upcoming versions as well. So yeah, this is the process of adding new JavaScript translations. And if you are asking yourselves what can I provide JavaScript translations for, the answer is pretty straightforward. Almost to anything. We basically support instance methods, we support also static methods, and we support extension methods. .vvm even supports some advanced constructs, such as variable arguments length, using the params keyword that you may know from C#. And if you want to know where are the limitations, where it mostly all boils down to the fact that we cannot basically support by reference arguments, so C# keywords such as ref, out, or in. Methods with these types of arguments are not and will not be supported. But other than that, I think pretty much every method that you can think about should be able to provide a JavaScript translation for. So if you find a .NET method that would be beneficial for you from your own code base to be callable from value bindings or static commands, you can now just write a JavaScript translation for that, have it registered by the .vvm configuration, and our compiler will automatically pick it up and it will just work for you. So this is it for the JavaScript translations. And right now I would like to approach the last topic of this presentation. And in this topic, I'll be speaking about supported types in view models and collections and operations that you can use on these types and stuff like that. What's changed in the recent few versions of .vvm. So yeah, let's get straight into it. So what can you actually write into view models and have it serialized correctly? So you can work pretty much with almost every numeric type, so ints, longs, and decimals, and whatever you can think about. Also chars, and from the non-primitive types, there is support for the basic stuff such as strings, GUIDs, enums, datetimes, and of course for all value types, we are also supporting their nullable versions. When it comes to collections, we support arrays, lists, and even dictionaries that you can use inside your view models. And if you want to create your own custom types, the rule for that is basically very simple. Whenever your custom type consists only on previously supported types, your type is also automatically supported. And there is one little addition that we are introducing in .vvm 4.1, which is now already in preview, and that is that we are supporting also records and structs. Not only classes anymore, so since .vvm 4.1, you'll be able to use also records and structs. And since we also added a rich type metadata that's being sent to client side, we now basically made view models really safe. So since .vvm 3.0, there is a coercer that is checking that you are assigning always only supported values into every property, and this also introduced a bunch of other cool features such as immutable states and many performance features as well. So yeah, when it comes to supported types in view models, in .vvm, I think it was 3.1, we added support for dictionaries, and in .vvm 4.1, we are extending the support of custom types with records and structs. So since .vvm 4.1, I mean, you will be able to use these as well. But right now I would like to talk a bit more about collections, as these non-scalar types are quite common, and I would like to speak a little more about them and what you can actually do with them inside .vvm. So first of all, of course, arrays, simplest data structure there is probably. When you are working with arrays in .vvm, you can of course use indexer using those square brackets to access an element, to read an element, of course also to write an element, and when it comes to properties, we are supporting the length property, which from previous slides you should be able to now also implement yourselves, as we learned on previous slides. So when it comes to arrays, indexer and length property. And arrays, shouldn't be a big surprise, are represented as JavaScript arrays when serialized from .NET and brought over to client side. So yeah, arrays pretty simple. Let's get into something more interesting. So lists. Lists are basically resizable arrays, and we support way more operations there. So it shouldn't be a big surprise. There is also this indexer that you can use both for read and write operations on individual elements. And we also support basically define many JavaScript translations, so we can support also various methods. So we support methods such as add and add range, so you can add one or multiple elements using one simple method call. You can clear all the elements from your list, and you can also insert a single element at a specific index or a range of elements at a specific index. You can remove an element at a specific index, or you can remove even all elements that are matching a specific predicate. And of course, methods such as remove range, reverse the list, and even some extensions of our own that we introduced, such as add or update, remove first and remove last, all of which take lambda expressions as parameters, so you can describe some more complex operations on lists. And when it comes to properties, we support the count property, which is really similar to the length property on arrays. And yeah, I mean, lists are also represented as JavaScript arrays when brought over to client side in JavaScript. So yeah, but it shouldn't be that big of a surprise. And we also support one more complex data structure, and that is a new addition, I think introduced in .vvm 3.1 or 3.2. Dictionaries in .NET, as we all know, is a collection of keys and values. And when it comes to operations, we support, of course, again, indexer, both for read and write operations. And when it comes to methods, we support the clear method, the contents key query, and we support the remove method. If you are wondering why we do not support the add method, we didn't want to actually include this method because in .NET it has this behavior that if you are adding an element whose key is already in the dictionary, you would get an exception. Whereas if you are using the indexer for this set operation, it was just replace the key. And the behavior of throwing exception would be harder to replicate to JavaScript. And we also didn't want to throw exceptions needlessly. So we are encouraging users to use the setter capability of the indexer. But of course, if you feel like you would make use of the add method, you can just add the translation yourselves. And when it comes to the JavaScript representation of dictionaries, we are also using arrays, and the dictionary is stored as a collection of key value pairs, which are of course stored in no particular order. So that's the way that dictionaries are represented in JavaScript, if you were wondering how we are achieving this. So yeah, I mean, this is so much for collections. So what changed in the past few versions? Mainly that we added type metadata, we added support for dictionaries, we added a bunch of JavaScript translations, so you can perform various operations inside your static commands on these collections, which is pretty cool because you can do sometimes quite complex operations just on the client side with no communication with the server whatsoever, so it's really, really fast. And yeah, we also added support for dictionaries and support for structs and records, which will be released in the version .vvm 4.1. And if you cannot wait, you can actually try it right now, because there is already a public preview that should have this capability already for you to try it out. So yeah, and of course I wouldn't forget about the many other methods that you can actually call on these collections, because we also provided in the past couple of versions a lot of JavaScript translations for many link methods. So you can use various link methods to basically perform, for example, client-side filtering of many sorts. So, for example, here I have an example. So let's just suppose that you, for example, have a repeater where you want to render on some special case, on some special page, only customer with first name Ben. So for example, it might be the Names Day and you would like to send a Happy Names Day to them. So you can filter them easily as this. You would just call the where linked method on the customer collection that you have in your view model, and then just perform the filtering using a simple lambda function. And as I told you before, you can check out our documentation where there is a really long list of all the methods that we are supporting, and in recent versions we added a bunch of more, for example when it comes to string method translations, or even some translations on date times and so on and so forth. So yeah, these are the main operations that you can use, for example, when working with your types inside your view models. And yeah, I mean, just to conclude this presentation, use our tooling, both our Visual Studio Extension and the Roslyn Analyzers. They are both pretty powerful tools. They can help you with writing your .vvm code. Not only that they provide these nice functionalities such as IntelliSense, code completion, and stuff like that, but it can also be helpful when discovering some issues inside your code, so you can react to it much faster, rather than later finding out during runtime that something crashed or couldn't be compiled and stuff like that. So yeah, in .vvm 4.0 we introduced Roslyn Analyzers that would guide you when writing your for example view models, and making sure that you won't use something unsupported. So you can also, as we learned in this presentation, extend our binding system with your custom JavaScript translation, so you can use some new shiny .NET methods inside your value bindings or static commands, which is a pretty nice feature and a quite nice way on how to improve the binding system and learn it to work with new .NET methods. And of course, in recent versions, we introduced into view models rich type metadata. We added support for dictionaries, and also when it comes to custom user-made types, since .vvm 4.1 we will be also supporting structs and records, so not anymore only classes. Also these other tools will be available for you when writing your .vvm applications. So at this point, from this presentation, it will be all from me, but stay tuned for our next presentation. In the next presentation, I'll be talking about many validation improvements and our roadmap for the next versions. And so after a short break, we will be back live. And until then, thank you for your attention.